Hello everyone, hope all is well today. My name is Jilamat. The topic of discussion for today are bar plots to describe the association between two categorical variables from a table, a contingency table. Okay, so first of all, what I would like to do is just show you the bar plot that I would like to construct. So here we have the distribution of cholesterol according to age group. Here we have two age groups, old and young, and cholesterol levels are actually displayed in the legend, which are low, medium, high. So we have a nice bar plot here that could be used to describe the association between the two variables. Okay. So the first step to construct such a plot is actually to construct a table. And so here what I'll do is go into my editor window. I already wrote down some commands that we're going to be using. I'm going to select the commands used to construct a table. I will submit them to the console by using Control R because I'm on a Windows machine. On a Mac, this is Command Enter. And then I'll go to the console to explain them. And so here we constructed a matrix object that we call table. So to display this object, I'll just enter table. And so here we see a table. This is a cross classification of our subjects according to two variables. The categories of the cholesterol level are in the columns, and the categories according to their age is in the rows. Okay, so I use a function called matrix. I put in a numerical vector. I have three columns, so I indicate n call equal to 3, and by row equal to true, this is indicating to R that I'm going to enter the values into the numerical vector by row. So the first three values are the first row of my table, and then the next three values are the next row in my table. Then I use the functions called row names and call names to give names to the rows and the columns. Okay. So the function we're going to be using is barplot. So if I use barplot of my table, then what we see is the following. So here we have a distribution of age according to the cholesterol levels. This is not very descriptive. It's missing a legend, missing a title, and also it's very difficult to compare these different groups because we actually have different number of subjects in the different cholesterol levels. So I have more medium than low, so it's very difficult to compare than the young across these different groups. Okay, and so this is a problem. I'll show you how to fix this. And then maybe I want rather the conditional distribution of cholesterol level according to age. And so what we'll do is instead of using table, we use the transpose of the table. So this is T of table. And so now in my columns here I see low, medium, high. So this is the distribution of cholesterol level, which is displayed in my bar plot. And so we have distribution of the cholesterol level according to the age. So for the old subjects, we have the distribution of cholesterol level. For the young subjects, we have distribution of cholesterol level. And again, we have different number of subjects among the groups, so this causes a problem when we're actually doing the description. So we have to fix this. Okay, and so first thing I'll show you is actually how to work with a function called prop.table. And then I'll select them and then explain what it's doing. So prop.table of my table, essentially it's giving proportions across all the entire table. So if I look at my first cell here, I have about 14.3%. What is this? Well, among all subjects, we have 14.2% or 14.3% that have low level cholesterol and they're old. 10.1% have medium level cholesterol and they're young. Okay, what I would rather want is actually proportions across the rows. So here I would like to have my old subjects represent 100%, my young subjects represent 100%. So if I put a 1 in the second argument in the function called prop.table, what I'm doing is getting row proportions. So if I fix my row, so if I look at the old subjects, I have about 21.6% that have low level of cholesterol, 43.1 that have medium level of cholesterol, and so on. If I put a 2 in the second argument, then this gives me proportions according to the columns. And so if I have a low I fix low, so low level of cholesterol, then I have 51.4% of these subjects that are old and 48.6% of these that are young. Okay, so what I'm going to do is actually save the prop.table that gives the row proportions. Okay, and so I'll get row proportions and assign them to my object called ptable. Okay, now we're going to be, or here, I'll just go to the function which creates the bar plot. I will submit it and then show you what it looks like. And so now here we have T of ptable. So these are the proportions according to the rows. And the T is just to give the transpose. I did times 100 so that it's represented not a proportion but rather as a percentage. So this is easy to comprehend. And so we have about a bit more than 20% among the old subjects that have a low level of cholesterol, I believe, and close to 40% of the young subjects that have low level of cholesterol. Okay. XLab, this is just to give a label, so I want age groups at the bottom here. YLab is to give a label to the y-axis, this is percentage. And then main is to give a title. Look at the /n, this is actually to put the title on two lines. So the /n is actually a break line. So if I take off my break line and then resubmit my command, so here I have the title across now one line. Now since the title is long, it's probably better to use a line break. So /n to use a line break. Okay. Call, this is to give colors. So if I just select gray.colors3, submit this to my console, what it's doing is creating a vector with 3 different levels of gray. And so gray goes from black to white, and then the levels, different levels of gray is going to what we're going to be using to identify our groups. Okay, and so I have call equal to gray.colors3 is just to say that I want three of these colors. Okay, so this is our bar plot. Now it would be nice to actually add a legend, because here we don't know what the different colors represent in terms of the groups for cholesterol level. And so I'll add a legend. And then I'll explain its different components. And here we don't see it because I have an inset. What I'll do is I'll put an inset back to 0, 0 and explain what it's doing. And then this is actually moving the legend. And so I now have a legend, and I explained how to construct it. And so we can either put it at the top, the bottom, top right, top left, bottom right, bottom left. I decided top right. I'm going to use the vector call names. This is just going to identify the 3 different groups. And then I use an argument called fill, and this should be actually the same vector in terms of grayscale that I used to construct the bar plot. Okay, so I used gray.colors with 3 levels. The inset, this is just to move my legend. So here I see the legend is on top of my bar plot, so I would actually need to move it. And then I gave a title to the legend called cholesterol. And so now what I'll do is I'll move it a bit, so I'll use an inset, and this is in terms of the x and the y axis, and so this will allow me to move the legend a bit. Okay. Now again, it's not nice, and then as I move it too much, I'll actually lose my legend. So what we need to do is actually play around with the margins. Okay, so now I need to show you how to play around with the margins. I'll use an inset of -0.35. And actually this is going to be a nice graph with this inset. So now let's go to here par. So par is actually an object which is used to manage information for the graphics window. And so here mar is for the margins. So here I'm displaying the margins, so 5.1, 4.1, and so on. And so this is margin in terms of bottom left top and right. And what I'm going to do is actually save the current margins so that I can reset the margins after I'm done doing my graph for future graphs. So I'll create an object called old margin with the current margins. Okay, so if I display old margin, this is actually the current margins. And then what I'll do is actually construct or change the margins. So now I'll use 5.1, 4.1, and so on. And then what I want to do is actually move the margin on the right, make it much larger so I can put in my legend. So I'm going to change the margin from 2.1 to actually to 8.1. And then another argument is xpd equal to true, and this will allow me to put the margin on top of the enable to things to be drawn outside of the plot region. So on top of the at the exterior of the margins. Okay, and so I'll send this command. So now my margins are changed, and then I resubmit my commands, and then now we change the margins, are much larger, and we're actually outside of the plot region here to display the legend. Okay, and we have a nice graph. So last thing to do is actually just to reset our margins to the previous or the previous margins. So I'll use par mar equal to old margin just to reset the margins, and then if I do par mar for margins, I see that the margin on the right is back to 2.1 and not 8.1, which was the original margin. Okay, so this is how you construct bar plots inside of R or with R. Okay, have a good night.